Welcome to part 7 of the Grammar of Graphics. So I solved the issue with figuring out how to make sure that the mean of the response variable is what is showing on our plot. So we're continuing on now learning about the statistics layer. So here was the line 62 through 64 is how I made this plot, and the statistics layer is on line 64. And I showed you that the primary feature of the statistics layer was this function mean, but we also were able to put in two aesthetics, color and size, as well as a geom on that statistics layer. We can use a position argument to adjust the position of elements on a graph. So when I saw the mean for the subcompacts right up here, you see here the ones that are near a displacement of 2, just under a displacement of 2. Look at that mean. That doesn't seem right. If there's only these 2 points here and we have a mean up near here. And so I thought there must be more than just those 2 points. There must be additional points. So I'm going to add a geom that's a position geom, referred to as a position geom. That is, what it's going to do is take another geom, namely points, and it's going to jitter those. So I'm going to use geom jitter. So that's the only thing I've added to the previous function. And so let's go ahead and run this. And here's what we get when we jitter. And actually, let me jitter it again. It will use a random function to jitter, and I'm trying to jitter. So it looks like if you look up here, I wish it had a little more jittering, and actually I could get in more jittering. In the documentation, it says that an argument that you can have is height and width. I'm going to do width to indicate how much jitter you want. Now, I'm not sure how this is going to turn out, so we're going to learn together. In the cheat sheet, they have width equal 2, and so I'm thinking that must be the default. Let me actually put in start y width equals 2 and see if that changes anything. Yeah, way too much jitter. So let me put in width of 0.5. And still a lot. Let me put in 0.3. Not enough. Put in 0.4. Little trial and error going on here. Okay, well that does what I need for this purpose. So what I was going to show you here is here are these 2 points right here that I'm pointing to, a little bit less than 2 displacement, something about 1.8. It looks like there's 2 points. Well, actually, this 1 point up here at the top is really 2, and that's what that jitter is showing you. There's 2 values right on top of one another, and you can't see them here, but this shows me that I actually have 3 points, not 2. See the black points here? 1, 2, 3. That has 3 points, not 2, and the mean is the mean of those 3 values. So I use the jitter to try to help me understand those means. Okay, let's do some more with the statistics layer, and actually what I'm going to do now is show you that before I go back to statistics layering, I'm going to show you that we just used a positioning here, a position layer, that some geoms have position layers built in. So the default position layer, for instance, for a stacked bar plot, the bars must be positioned on top of each other so as not to overlap. So when I run this, in which I'm using the type of car as my horizontal axis, and I'm using the DRV, which is the type of drive, 4-wheel, forward, or rear drive. So that's where the engine, whether it's making all 4 wheels turn, whether it's only turning the front ones or turning reverse, Those are designated by my fill color here. And the geom bar, where I say position equals stack, that stack is actually positioning the bars. So this is one bar and this is another one stacked right on top. So it's like a position layer. Here I'm going to normalize the height to make all bars the same height, which is something I like to do for proportions for a bar graph. So let's go ahead and do this. So this is my actually favorite way to do a bar graph. The only difference here, though, is that we no longer have counts, we have proportions here. So I'm going to need to change that label, and we're going to figure out how to do that later on. But here the proportion is all 100%. And so we can see that minivans are 100% forward drive, whereas two-seaters are 100% rear drive. But we can buy things like a compact car that can have either four-wheel drive or forward drive. Here I'm going to create side by side. So again, notice the position argument here. The position argument, now instead of stack, it's saying dodge. So make the bars dodge each other. And that creates a side by side bar plot. Okay, back to statistical layering. Some geoms have statistical transformation built in so that you don't need a separate line. These are transformations that make sense. For example, if we are using geom bar, we're going to want a statistical transformations that uses the count of points rather than individual points. So when I run geom bar, it's not using individual points, it's counting them, which is a statistic. And so the statistical layer is built right in to geom bar. If I want to use statistics based on individual points without doing any transformation, that's the identity transformation. So in the function below, notice the identity is the default. So let's see what I'm going to be doing down here. I'm going to be taking an aesthetic for the entire global aesthetic of X for displacement, Y for highway, just like we did before. I'm going to make color class for geom point, and I'm going to use the smoothing function. So geom point automatically here uses the identity transformation, meaning don't change the points. Okay, I know that's a little bit technical sounding, but if you think of every geom needs a transformation, well then just make the transformation multiplying by 1 and you end up with the identical points. Notice the stat smoothing function gives us a non-linear regression through the points. This is curvilinear. Tries to fit them as well as possible and also gives us a confidence bar. You might be wondering if there's a statistics function for a linear model. Of course there is. It's also smooth, but instead of using the default method, we use LM. And there you go. So we have now a linear regression line through the points. We have a confidence interval about that regression line, showing us if we were to take multiple samples, the regression line would still fit somewhere within that interval, nice and narrow. I like that. Well, next we're going to consider the scales layer, and that's a new layer, so let's save that for a new video. I'll see you then.